The diagram shows circles with centers Q and O and MTR. So MTR is equals to 40 degrees. MT and RT are not necessarily tangents to the smaller circle. Determine firstly Q2, O1, PMO, and lastly P. So let's first determine Q2, this angle here. So we know that to determine Q2 here, I want you to focus on the big circle. So we have QMTR, which is our cyclic quadrilateral. Okay, so we know that opposite interior angles of a cyclic quadrilateral add up to 180. So in other words, for us to calculate Q2, we're just going to add Q2 and 40 degrees because they are opposite. So we're going to say angle Q2 plus 40 degrees, which is this angle. They add up to 180 degrees. We know that the reason for this is that opposite interior angles of a cyclic quadrilateral are supplementary. Okay, and then so we can then determine Q2 by just saying Q2 equals to 180 degrees. We take this 40 on the right hand side, it is positive. And when we take on the right hand side, it will be negative 40 degrees, which makes our angle Q2 to be equals to 140 degrees. And then we are required to determine O1. So we need to determine this angle here, angle O1. And then still looking at this cyclic quadrilateral MTRQ, you can see that we have O1 as the angle at the center. And then we have 40 degrees as the angle at the circumference. And we know that angle at center, it's twice the angle at the circumference. So we can then say for 3.2. So this is 3.1. So for 3.2, we can say O1, angle O1 is equals to 2 times angle 40 degrees. Okay, remember that the reason is because of angle at center. So angle at center equals 2 times the angle at the circumference. Okay, so our O1 will then be equals to 80 degrees. And then we are further required to determine PMO. So we need to determine this angle here, which is PMO. Okay, so this entire angle here. The easier way for you to solve this one is that you need to break this angle into sub-angles. So we can start first by saying, okay, let's start it here. Maybe we have 3.3, right? So PMO, angle PMO, is actually equals to angle M1 plus angle M2 plus angle M3, because this makes angle PMO. So we know that PMO equals to angle M1 plus angle M2 plus angle M3. Okay, so let me just draw a line here. Okay, so if you could find M1, M2, and M3, we'll then be able to find PMO. Okay, so firstly, to find M1, M2, and M3, looking at the smaller circle, we can see that we have triangle RMP. And then this triangle has a diameter PR. Okay, making this angle here a 90-degree angle, which is angle in a semicircle. Now, this will then give us the right to say angle M1 plus angle M2 are both equals to 90 degrees. Okay, M1 and M2, they are 90 degrees because it's an angle in a semicircle. Okay, so we managed to find M1 and M2 just like that. So we are only left to find angle M3 now for us to be able to find PMO. Okay, so to find angle M3, we can look at the bigger circle now. Okay, we are looking at the bigger circle, and then I want you to focus on this triangle in the bigger circle. We have triangle MOR. Okay, so looking at triangle MOR, we can add these angles inside this triangle to find M3. Okay, so let's go. We have angle O1 first. Okay, so we're gonna say angle O1 plus angle M3 plus angle R2. They all add up to 180 degrees. So we know that this is sum of angles in a triangle. Okay, but guys, look at this. But remember that OM is equals to OR. So we can then say but angle M3 will be equals to angle R2. But M3 is also equals to R2. Why? This is because OM and OR are what? Are radiuses. So OM is equals to OR. So we can say OM is equals to OR. This is the reason, making them both radiuses. So we're going to say radii here. Okay. So if these two are radiuses, this makes triangle ROM an isosceles triangle, making M3 be equals to R2. Okay. So but M3 equals to R2. So we can then substitute here. So remember that we found O1 as what? As 80. So we're going to put 80 in the place of O1. So we're going to have 80 degrees plus we have M3, right? Angle M3 plus we have R2. But instead of writing R2, we can then write M3 because you know that M3 is equals to R2. So we're going to write M3 equals to 180 degrees. Okay. So now we can say 80 degrees plus M3, we know that it's 2 angle M3 equals to 180 degrees. Then from here, we can then say, take this 80 on the other side, we are going to be left with 2 angle M3 equals to, we have 180 degrees. We're going to take this 80, it's positive, and then when you take it to the right, it's going to be minus 80 degrees. Okay, so we have 2 angle M3 will be equals to 180 minus 80. We know that will give us 100 degrees. Then we divide by 2 on both sides since we are looking for M3 only, not 2M3. This will cancel out with this. Then this will give us angle M3 is equals to 50 degrees. Okay, so we managed to find angle M1, M2, and M3. So we can just add angle M1 and M2. We know that M1 and M2 is 90. And then angle M3, we know that it's 50. We know that 90 plus 50 will give us 140. So we can then say therefore, angle PMO will be equals to 140 degrees because we added this 90 plus 50. Okay, so we managed to find this question. So let's go to the last question. So the last question, they're saying that we need to calculate angle P, this one here. So we need to calculate this angle P over here. So in order for you to calculate angle P over here, I want you to focus on the smaller circle again. Okay, and then focus on triangle RPM. Okay, remember that we have Q2 here. We found Q2 as 140. So for us to find P, we can maybe calculate Q1, and then Q1 will then lead us to calculating P. Okay, so I'm going to utilize this space here. So we know that we can calculate Q1 by Q2. So Q1 and Q2 are angles on a straight line. So we can say angle Q1 plus angle Q2, they add up to 180 degrees because these are angles on a straight line. Okay, These are angles on a straight line. So we managed to find Q2 as 140. So we're going to have Q1 plus Q2, we put 140. 140 degrees, they add up to, they are all equals to 180. So this will make our Q1 be equals to 180 degrees. And then we take this 140 on the right hand side, it's positive, then it's going to be minus 140 degrees. Okay, this will make our Q1 be equals to 180 minus 140. We know that will give us 40 degrees. Okay, so remember that we managed to calculate Q1 now as 40. And then the question is that we need to calculate P. Okay, so we can still use the same method that we used here. If you can look at this, QM and QP are radiuses, right? So we can add Q1, M1, and P. Okay, so we can then say to calculate P. Okay, let me just create a space here so that we can utilize it. So to calculate P, we can say Q1, this one here, plus P, angle P, plus angle M1. Remember, we are adding these angles in this triangle QPM, okay? They all add up to 180 degrees. Since you don't have a space, you know that these are sum of angles in a triangle, okay? So we need to then substitute, but before we substitute, you need to say but angle P is equals to angle M1. Remember that P is equals to M1. Why? Because QP and QM are both radiuses, making this triangle an isosceles triangle. Okay? And then making this and that be equal. Okay? And then from here, what you will then do, you will say Q1. Remember that Q1 is what? It's 40. So in the place of Q1, we put 40 degrees. Okay? Plus we have P, angle P, plus M1. So instead of writing M1, we write P because we know that P equals to M1. So we're going to put P here equals to 180 degrees. Okay? And then we have 40 degrees. Then plus P and P, we know that give us 2P equals to 180 degrees. Okay? Since we don't have enough space, I'm just going to say we have 2P equals to 180 minus 40. We know that it will give us what? 140 degrees, right? And then to find P, we know that we're going to say 2 divided by, we're going to divide by 2 here and here, which will give us 140 over 2. It's 70 degrees. So this is how you solve this question.